Hi everyone, in this video we are going to discuss our different units of energy. So in this video specifically, we're actually just going to discuss our three main units. So let's go through these very carefully. Our first one, and my favorite one, is the joule. This is the one I'm going to use all the time. So 1 joule is just equal to a kilogram meter squared per second squared. So obviously, I think it's clear why we'd rather use just J or joule instead of always writing kilogram meter squared per second squared. So 1 joule is just a unit of energy, and it's telling us how much energy is being transferred or released or absorbed based on whatever the context is of our problem or situation. The next unit we like to talk about is calorie. Now this is a lowercase c, and that's important, and I'll tell you why in a second. Lowercase c, we refer to it as cal, C-A-L, all lowercase. Now, the one thing we want to talk about is when I say the scientific calorie, lowercase, we're saying scientific. It's specific. We need to refer to it as a scientific calorie. Now, 1 calorie is equal to 4.184 joules. Memorize this. Get this down. It's a very, very important conversion. You must know this. Now, the reason I was very specific about lowercase c, because there's also something called a nutritional calorie. This is the one you're probably more familiar with. This is a capital C, okay? So this one is the nutritional unit. Now, when I say nutritional, I mean because when you count calories, you're actually counting big calories. You're counting nutritional calories. The calories reported on the back of a candy bar or some chips or whatever it is, those are big C calorie. Those are your nutritional calories. So the reason there's a difference is because 1 calorie, big letter C, is actually equal to 1,000 scientific calories. So that actually means it's equal to 1 kilocal. So 1 big calorie, nutritional calorie, is equal to 1 kilocal scientific calorie. More importantly, we can go through an example and talk about this in terms of calories and units and whatever, but let's talk about it in terms of gummy bears, okay? So 1 gummy bear, this is very important. 1 gummy bear is approximately equal to 10 nutritional calories, okay? So 10 nutritional calories we would say is equal to about 10,000 scientific calories. Well, 10,000 scientific calories would be equal to about 41,840 joules. So let's see what happens when you put a gummy bear inside of your body. So what I'm going to do right now is show you a video of something I did a long time ago in class, so it's not perfect. So that's me, that's my my TA. And so what we have right here in the center is there is a test tube, and it has something called potassium chlorate in there. And what we've done is we've liquefied it, and now what I'm doing in my hand is a gummy bear, and I'm going to drop it in. And so listen carefully.
Okay, you guys ready?
I get nervous. You see that? Isn't that cool? Okay, that is what happens when you put, oh geez, get out of here, when you put 1 gummy bear into your system. So your body, your metabolism is instantly trying to digest that. 1 gummy bear, think about that. 1 gummy bear, every time you do that, is 41,840 joules of energy that you're putting into your body. So please eat healthy, okay? That's my one little caveat I want to add in there. All right, so let's do a problem using these units that you need to understand here. What mass of coal, going back to combustion, in grams, I'm being very specific here, what mass of coal in grams must be burned in order to release 1.31 times 10 to the 13th joules of energy, okay? But in order to do this, I need to give you one quick conversion. We're going to tell you that 1 gram of coal, and so we have to be specific because it's going to matter on what unit or what fuel source, but 1 gram of coal in general, on average, can release around 29 kilojoules of energy. All right. Try that problem. All right, did you get an answer? Hopefully you did. This required a little bit of dimensional analysis, a little bit of math, so hopefully you were able to hang in through there. But let's start from the beginning. Always start with what you know. So we know 1.31 times 10 to the 13th joules of energy were released. Joules of energy is on the top, which means I need joules of energy on the bottom. So now this gives me a unit in kilojoules, so I know I have to get my joules of energy that was released here, this 1.31, out of joules and into kilojoules. So I know for every 1,000 joules of energy, I have 1 kilojoule of energy. Now, we're in kilojoules. We're trying to get to grams eventually. We are given a conversion of kilojoules to grams, so all we have to do is apply this information. So we have kilojoules of energy on the top here, so we need kilojoules of energy on the bottom here. So we know for every 29 kilojoules of energy release, we typically burn about 1 gram of coal. And so we're trying to get in grams of coal. We're done. Check our units. Joules of energy cancels out with joules of energy. Kilojoules of energy cancels out with kilojoules of energy. We're left of grams of coal. So if you do this properly, so you take 1.31 times 10 to the 13th joules, divide by 1,000, divide by 29. If you do that properly, you end up with 4.5 times 10 to the 8th grams of coal. That is a lot of coal has to be burned in order to release a lot of energy. And so this is how much coal is typically burned per day in an average U.S. power plant. Take care of yourselves, drink water.